This video and associated handout concern the processing of typical LC MSMS data files in NIST26 Chromatogram window. And it's part of a basic introductory course on accurate mass LC MSMS. The chromatogram window performs deconvolution of accurate mass MSMS spectra in an accurate mass LC MSMS data file. Then library searches the resulting spectra to yield the best library search for each spectrum. It's based on the NIST MS PEP search, and you can see the references below. But you can really think of it as the NIST26 chromatogram window functions as a personal assistant for LC MSMS data interpretation, then automatically organizing, grouping, and prioritizing the MSMS spectra so routine spectral library searching becomes practical for everyday analyses. Configuring and navigating chromatogram window NIST26 and associated help files. This is a very useful detailed information on Windows manipulation and help files. It has additional information in the NIST26 Comprehensive Users Manual, but this built-in help files is very useful for, and also manipulating the windows. So you might want to watch this before you take the class on the chromatogram window or after, just to take advantage of some of the other attributes. And it's found within the tutorials called Configuring and Navigating Chromatogram Window NIST26 and help files, and it also has an associated handout. So we'll go to the actual program to demonstrate the use of the software. So we'll go to first our program group and open the program under NIST MS Search Demo, MS Search. When you first open it, it's pretty much got the default settings you need, but we'll go up to the file and analyze an MSMS input file. We'll do the positive IN file that they've supplied with NIST, but we'll check a couple of things to make sure the library we're using is correct. I've got these extra libraries on here, but they've designed this one for this particular file, so that's the one we'll use. So that's okay for now. The tolerances are 20 for the precursor ion and 40 for all the product ions. It's very reasonable values. And we'll just go find our file. I'll put all the files within the tandem demo in test files. And so the one that they supplied is this positive ion one. I put my files in the same folder as their test files in their folder for convenience. You don't have to be. You can actually look for the files anywhere and open them. The libraries have to be a particular place, but not the files. And so we'll say, okay. It's doing its work. It's a fairly big file, so it probably took around 20 seconds for the results to show up on the screen. But what we have here is essentially our MS1 chromatogram shown here. The little dots show the peaks by abundance. So a relative abundance, this has a relative abundance of 65.4, you can see. So these are abundance. And you notice there's an axis over here for abundance, and there's also an axis over here for the total ion current. And you can kind of manipulate those separately. So if you want to change the properties, a lot of times we've got these small abundances down here. You might want to look at it on a log scale if you want to. And it just kind of brings things up so you can see them better. So you can actually see the differences between these small spectra. But there's a lot of information here that I don't want to look at. I just want to look at the major components. So I'm going to go to Properties and go back to Linear. Okay, I right-clicked on the window to go to Properties. And now I think you can sort by anything you want to when you click on a column. So I'm going to sort by abundance relative. And now you can see hundreds at the top, and that's just relative. And remember that responses in MSMS are not directly related to concentration. It's just the abundance of the data in the MS1. So I think I'll pick everything that's above about 6%. So what I did to do that, I used my keyboard equivalent. So I held the Shift key on my keyboard while I picked the first one in the list and then held the shift key and went down to where I wanted to stop. So I went down to, let's say, about 4.7%. And then you just say, I right clicked on that blue area that I highlighted and say, show selected. Now it got rid of a lot of the small peaks that I wasn't interested in. And I like to look at things from left to right, so I'll resort by retention time. Clicked on it once. We'll expand it a little bit by clicking and dragging. I'll sort again because to get the smallest, the earliest retention time. And then what you can do is you can select what you want to. I think I'll start with this one. So I'll click on that one. Now I'm going to the bottom and putting my mouse on it. And now I can use the keyboard arrows to go left and right in the file. So I'm going with the down arrow to go to the next one. What you see over here at the top are the results. You see the unknown on the top, and you see the best hit from the library on the bottom. And so you can essentially just step through them fairly quickly and look at the results and kind of just take a overall view to see if what looks good about it, if you want to change anything. You'll notice when I made these peaks go away, you can easily right click and say show all again to go back. And it's a good idea to keep an eye on this hits at the top, this 573. That's actually how many hits it had in the data file. It picked up library searches on all these very small peaks, and that's why it took a while to open this file. But as I did before, we'll sort by abundance again. Just to go through the process again. I'm holding the shift key. I'm going down, getting everything above 4.5 relative abundance, and then right clicking on the blue box that I selected and say show selected. So now you can see at the top I've gone to 18 components, which is much more reasonable for looking at. So everything looks pretty good in the default settings, but I would suggest I really like to have the structure displayed up here. So I will right click on it and go to properties. You can always go to the properties to change things, and I want the structure on the plot. For reviewing the data, as I'm stepping through it with arrows here, I'll go back and step through with a couple of the arrows to see. I like seeing the structure directly under the known versus the unknown. And you're really just deciding if the data looks reasonable to you by reviewing it. It also has a structure down here, and you can also have another window where you can have a floating structure. You can say show structure. I don't typically use that, but you might like to use it. You can put it wherever you want to in the program. I usually do manage with just having the structure here. So that's pretty much how you manipulate the data. The other ways you might want to do it, I'm going to right click on it again and say show all. And then I think in this time, instead of doing abundance, I'll just look at the things with high score. So I click on the score, which is the based on a thousand, so the highest or the best fits. And I'll just pick the things that have hits above, let's say a score of 82. So I used my shift key again and then click the first and the last to get the range, and then said show selected. So that gets it down to the basic ones that way. It makes it a lot easier to review. So again, I'll resort by scan because I like to look at the from left to right, lowest to retention time to highest retention time. And then you're set up just to click through the arrows on your keyboard to review everything. So all the results look pretty good for this test mixture. They also have a negative test mixture. If you wanted to, you could process it by going to Analyze and picking the negative file that they have. But I'll leave that as an exercise for you to try. So let's right click on the bottom again and say Show All. Get back. See, we're down to 13 hits if you look at the top, but now we'll say Show All. There's some other things at the top of the menu up here that I'd like you to show. It's got best hits. You should leave that on all the time. We'll talk about that in the another sample, but use that. You could put only IDs because sometimes it says no ID. So if you wanted to get rid of those, we're at 573. If you get rid of only things that are identified, you're only down to 14. So really, you could have used that as a filter. You'd highlight the scores. The background corrects for just noise in the data, and usually 90 or 75 is a good value. Let's look at if we go back to any. See, it goes to 4,858. So not having that noise background filter on makes a huge difference. So let's usually go with the 90 as the default that they liked. And you can also filter things by the abundance threshold if you wanted to do only things 1%. So there's lots of different ways to filter the data, but we'll just go with what they had for here for now. Put it back on auto, leave the background on 90%. I think we'll turn on the we'll leave that off for now also, but you also ought to make sure that you've got these filters set where you think you should be, or you'll be taking out a lot of data. A lot of times you can just turn them off and then start to bring them in and watch this number of hits as it changes. Of course, within this data, you can left click and drag and only get the ones shown within this area. And if you double left click, it goes back. You could have said undo zoom. Up here, you can zoom also the results if you want to. So if we click, I'm going to click on one that it had some results for. So here's a nice fit here. You can see the score is very good on that, 899 out of 1,000. Score unfiltered would talk about in more advanced scores. The dot product is more like a raw score, and it's not been filtered for certain parameters that give more better results. So you tend to not use the dot product. You use the dot product, and it's modified by other parameters to give you the final score. It shows the abundance, of course, the precursor mass to charge, databases. If you're using the whole NIST library, if it's in a database, they have bunches of different databases that they reference to. And if it has a very high number, that tells you it's more likely to be the correct identification. We'll turn off the only IDs again, just to make it a little simpler. That really simplified things a lot. And you can expand up here if you wanted to look part of it. So I left click and drag. But if you right click on this, there's no unzoom. So you have to double left click to get it to go back. So that's pretty much some of the basic settings. Over here you have the information about where it came out of the file, and below is for the best hit, it tells you the information about what was in the library. I want to demonstrate the software with another file, one that I supplied and I used in a previous tutorial with you. So we'll go up to File and say Analyze MSMS Input File. Here we want to make sure to search all the libraries, so I'd already changed them. But if they weren't, if let's say only the demo lib was selected, so maybe those will go away, you'll only have 830 Spectra. That's the library they supply with their demo files. But I want to do all of them, so I'm using the Shift key to select them all, click the first one, the last, and just say Add. Now we've gone up to 522,000 Spectra that we will search for this example. Okay. The tolerance should be still 2040 for the precursor and the fragment ions. And to get the file, I'm going to do this forensic tox test mix. It's a automated acquisition file, and say OK. It ran a lot faster than the other file because there's fewer peaks. So if you turn everything off on the background, you'll see we're 105, but if you get rid of even that, the hits only go up to 238. So much fewer small peaks in it to filter out, but we'll put it back at 90. That's a good number. We'll go with the only IDs clicked. Well, let's click it off and see if it matters. It goes from 105 to 135. So there were 30 things that it couldn't identify using this library, but I'll turn that back on. I wanted to show you how, before I showed you how to use the Shift key to select a range by selecting the first, hold down the Shift key on your keypad, and pick the last. So first and last with the Shift key. You can also pick individual ones if you want to. So if I wanted to pick this one, I hold down the Control key, and then I could pick this one, anything I wanted to, and then right click and say Show Selected. So that's how you do not a range, but individually picked peaks if you want to. So let's undo that. I just want to show you how to do that. So let's go back to show all. We're back to 105 hits up there. And now I just wanted to show you a few more columns that we had talked about in the other tutorial. So if you click out here, that's diazepam. And that's the example that I used. And you can see if you go down, it's a good fit, 904 for the precursor ion at 285, as we talked about in the first tutorial I used. So the spectra compares very nicely. Let's add a couple of more columns over here besides the basic one. So I right-clicked in the bottom window and go to Properties. And I'm going to include some advanced results because that's some of the things I talked about when we were looking at the original tutorial. So the number of spec. So I'm going to click that and add that column. And that would be a good one to do. And I want to do the XICs because we talked about XICs in the initial tutorial a lot. See if I can find it here. XIC number and say, okay. Now you'll see these other columns added. And if you'll remember in the tutorial, I said there were 9 peaks that were found that were related to the 472 bin. So it put everything in a bin. And I'll sort the XIC number just to show you top, bottom. You can see that the first one that it actually included in the results is 48, and it goes down to 559 bins where it's grouped these spectra that it thinks are all related to that one compound. In the case of the diazepam, click on it again. There were 9 spectra it thought were related to it, and it picked the best one. And you can see it is a nice fit. If you wanted to see uh, the actual hits for all of them, you could turn off best hits. It'll make it very much more complicated. Now you can see our 9 peaks. There's 1, 2, 3, 4, 5, up to 9. You can see some of them have pretty bad scores if you look at them. So click on the first one. I'm using the keypad and using the arrows. You can see I had a fit of about 900 for that, 901. They go down to as poor as 29. It grouped it because it thought the precursor accurate mass was good within the range, and it thought the isotope ratios for the ions it saw were good. But you can see it's a somewhat noisy spectrum, and that's why they picked the best hit, because it's better results that way. So if we put best hits back on, you can see for this peak, if we click on the abundance dot here, these are related to the abundance on this axis. That's how high they are above the baseline. And you'll see that we're back to having the best hit being diazepam with a really good fit. So those extra columns, you don't really have to have them, but if you want to understand what I showed you in the lecture, you'd find it useful. The other thing I wanted to show you for the diazepam, you can see it's got this chlorine. And we talked about things that had chlorine will show up as a distinctive isotopic cluster at the molecular ions. So I'm going down to diazepam and I'm right-clicking on it, and I'm saying send to XIC analyzer. It actually opened it up on my second screen, so I'll drag it over here for you and make it full screen. And you can see what I showed you. Here's the isotopic cluster showing very good mass accuracy for the precursor ion, and also the theoretical pattern. You can see the two different colors they essentially overlay. It's a very good fit to the generated isotopic pattern for that molecular formula. So this is pretty much shows you the isotope. So if you want to see, this is an MS1 spectrum here. This isn't the MS2. It's not the fragmented spectrum like we saw on the other display, but it's the MS1. And you can expand it if you want to by left clicking and dragging. Again, there's no unzoom there. You have to double left click to get back. So that window is very good to confirm the presence of compounds that have chlorine, bromine, sulfur, anything that has M+2 type elements. I wanted to show you one other thing you might add, one of the labels at the bottom here, the headers. I'm right-clicking on the space there and going to Properties. Another one I like to have is the actual library it found it in. So I'm looking for that in the choices here. Library. Say OK. And now if you expand it a little bit here, or the library. So you can see it. I'm left clicking and dragging the column. Now you can see which library it actually came out of. So I think that's another good addition. If it's always good to save your parameters. There's really no way to save it in the Chromatogram tab. So I'm going to the bottom here. I'm clicking on Lib Search tab over here, and I'm going to say File, Save Configuration. Now all those parameters that I've changed will be good. So I'll call mine JL, my initials underscore default, and say Save. And now you would be able to restore them at a later time, so without having to set up everything again. So it's good to save your parameters. And that's pretty much what I wanted to show you about using the Chromatogram window, the basic functions. It's a very powerful program, very easy to use. So let's move on to another topic. Good day.